want you to go ahead and put your dividers away. They kind of get in the way of stuff. And get our notes out. I think we have one more of these imaginary number things to do. So we'll take care of that. And then P6 will be done, and we'll move on into P7. So P6 will be due on Friday. That one's really easy. I don't know if you started that or not. P6 you should be able to apply to. But we do have this one problem. Over here due. Wait, no, where are we going? I'm like behind. We're ready. We're in P7, right, already? So P6 is due tomorrow? Yeah. Right? Yeah, we're already in P7. I was looking at the wrong thing. Am I in the right spot now? That's where I am? Okay, good. And we're solving this with our calculator. Okay. So let's go ahead and type it in. Hit graph. And I got a picture that looks kind of like this. If yours doesn't look, if yours is kind of squished up, go ahead and modify your window, kind of open it up a little bit, and I think we'll see this. Is that right? And here are the zeros, but we're not interested in where it equals zero. Well, kind of we are, I guess. Interested in where it equals zero. But we're also interested in where it is greater than zero. So does that make sense to you? Then you should be able to figure that out. If you're not sure how to do that, go ahead and lean over and ask your neighbor. That's what I got, but I'm open for any kind of conversation or corrections. Does that look okay? Easy. All right, let's take a look at a couple of word problems now. Projectile motion. Okay, you physics geeks will love this. A projectile is launched straight up from ground level with an initial velocity of 256 feet per second. When will the projectile's height above ground be this? When will it be at least this? And when will it be less than this? Well, there is a piece of information that you need to have in order to do this problem. You have to know the projectile motion formula. Okay? Anybody in physics happen to know it? The projectile motion formula, when we're doing things in feet, which this is a feet problem, right? Looks like this. T is time in seconds. V sub naught, that's how we read that, V sub naught, is the initial velocity. And H sub naught is the initial height. So the height of an object at time t can be calculated by this formula, given the initial velocity and the initial height. Those are numbers we're going to plug into our formula. So let's build the formula for this particular problem. So our height above the ground is going to be negative 16t squared plus what? What is our initial velocity? 256t. What is our initial height? 0. Because where did this thing start? On the ground. So the initial height is 0. I'm not even going to write it down because I don't like what's 0 there. But that's what the initial height is. If we were launching something off the top of the building, then the initial height would be 18 feet or however tall the building was. But this one's on the ground. Okay, so there's our formula. Now it says, when will the projectile's height above ground be 768? Now keep in mind, there are two variables up here. This is height, like y, and this is time, like x. So you have two variables. They're telling you that one of those variables is 768. We want it to be 768 feet above the ground. So where are we going to put that 768? Here. So 768 equals negative 16t squared plus 256. What kind of an equation is that? Quadratic? So let's get it set equal to 0. And then, just for fun, this would never happen in the real world, but this is a textbook problem. So just for fun, does 768 divide by 16? It does. So I'm going to go ahead and divide everything by negative 16. So t squared minus 16t plus 48. So I just divided everything by negative 16 to make my numbers manageable. And I think that backwards. What do you think? How is that backwards? Not 6 and 8, because 6 and 8 would add up to 14. 12 and 4, there we go. 12 and 4. So what does that mean? Answer the question. When is the object 768 feet above the ground? Twice. At 4 seconds and 12 seconds. Wait a minute, explain that to me.
Because it's going to fall back.
Once on the way up and once on the way down. Okay, so if you think about a picture of this, the ball starts on the ground, it goes up in the air, and eventually it's going to hit the ground again, right? And up here somewhere is 768, and it crosses the 768 line on the way up at 4 seconds, and it crosses the 768 line on the way down at 12 seconds. Okay, so when will the height above the ground be at least 768? So this answer to A is 12 seconds and 4 seconds. Okay? what is the answer to B? When will the height above the ground be at least 768? In between them, right? Wouldn't the answer to B be everything from 4 to 12 inclusive? That would be this little bump right here. And then, when will the height above the ground be less than or equal to 768? So less than or equal to. So maybe 0 to 4. Or 12 to what? Don't say infinity, because remember, that's wrong. Don't say that. What are we finding? We're finding when, right? When? Is this ball going to keep traveling down infinitely forever? No. Doesn't it hit the ground and stop? So we need to figure out where it hits the ground. Any thought on that? Olivia? 16. How did Olivia know it was 16? Because it's a parabola. But what do parabolas have? Symmetry. Right? So if this distance is 4, won't that distance be 4? So this should be a 16. Now you're going to be able to do any projectile motion problem, even when the numbers don't work out so great, because no matter how ugly the numbers are in the equation, your calculator will figure them out. Okay? It's easy. Now, number 4. This problem, a problem like this, it's called the box problem, is done by every pre-calculus student in the whole wide world. It is the classic pre-cal problem. Let's see. An open box is formed by cutting squares with the corners of a regular piece of cardboard and folding up the flaps. So here we go. We have a piece of paper. You know how big the paper is? Yeah, it's 12 by 15. So there's our piece of paper. Now we're going to cut a corner out. Cut these out. These out. And then I'm going to have flaps. You see them here? And I'm going to fold those flaps up and make a box with no top, just open box. Okay? What size square should be cut to yield a box with a volume of 125? So in other words, how big do these corners have to be if I want the volume of the box to be 125? How do you find the volume of the box? Rectangular solid. Length times width times height. So my volume has to be length times width times height. Okay, what is the length of this box? Now remember, the original length of the paper was 15. This is 15. What's this going to be? 15 minus 2x. And then the width was 12, but it's now going to be 12 minus 2x. And then what's the height of the box? X. Does that look okay to everybody? Now, when will the volume be 125? So this is our, like, basic formula, but we want the volume to be 145. Does that make sense to you? time multiplying it out. Your calculator can handle the parentheses. So if you leave it like that, you are gonna have to make a window adjustment. Remember, one of your equations is going to be y equals 125. So that's big. Yep, Caitlin, you get ready to raise your hand.
Yeah, I had 8 and 7
As a third answer?
Yeah.
Okay, let's talk about that. She got a third answer that's in an 8.870, something like that. Because, keep in mind, this thing is a cube. So cubes are going to go up and down. And she says, if this is 125, she got an answer here, here, and then there. And she's exactly right. But, you think about something for a minute. What is x? X is the size of the corner that you cut out. That paper is 12 inches wide. If you're going to cut a piece from each corner, and it's only 12 across, could that piece be 8? No. In fact, that piece has to be less than 6. So when I set my window up for my x, min, and max, I just took that into account and said, I don't know what x is, but given the parameters of the problem, it's bigger than 0 and less than 6. Does that make sense to you? So 100% there's a third solution, but it doesn't apply to this problem. So, what are the answers? I think right here. These two are the two places where the volume is exactly 125. Now, I want it to be more than 125. So would it more than 125 be between these two numbers? So then here comes an important thing. I want the volume to be at most 125. So at most 125 would be from 0 to 0.9 or 2. Would you agree with that? x can be 6. Because once you get to 6, your volume becomes 0. That makes sense to you? Just for fun, we've not done this yet, but what is the biggest volume we could make? With a piece of paper this size, what is the biggest volume we could make? We've already got everything we need. Now we just want to find this point right here, wouldn't that be the biggest volume? So we'll do our second trace and pick maximum. Have you done that before? Okay, there we go, let's find it. Oh wait, I can't. What do I have to do? I gotta type in one equation. So we want to maximize the volume. So take out the 125. We don't want that in there. We're just maximizing the volume. There we go. Now we go. All right, what do you got? Anybody find the maximum volume? I got 177.234. And that happens when x is 2.209.
I have a question with the answer for when it's less than 125. Can you explain why we put the brackets versus parentheses in places that we put?
Because you want to be less than 125. So if I let x be 0, what's my volume? 0. And is 0 less than 125? Yes. So this number gives me a number less than 125. This one does not. This one gives me 125. Right? Yeah. So my maximum volume is 177.234 cubic inches. And that happens when I let my cutout pieces be 2.209 inches. Perfect. All right, what's next? Oh, that was the end of P7. So P7 is due on Friday. And now we're going to start P8, which is all about systems or equations. We have already, we just did it right here. We solved the system graphically. Now we're going to do it algebraically, which means by hand. So, how do you want to solve this by hand? No calculator. How are we going to do it? Charlie? Send me a computer. Absolutely. It's called substitution. What's our other method we have? Elimination, right? We're going to use substitution. So, x cubed minus 6x equals 3x. So then we'll get it equal to 0. And then we'll factor and factor some more. And it looks like 0, negative 3, and 3. But remember, you're not done. Because we have two equations and we're looking where they intersect each other. So then their intersection be points. So here we go. is 0, what is y? If x is 0, so is y. If x is 3, y is 9. And if x is negative 3, y is easy peasy. Alright. Thank the Lord we're doing the next one graphically because this is not very pretty. But we can do it. I don't know how your window's set, but you might want to zoom 6 just to get that cleaned up. And let's put these in. So ln x, you have an ln button, ln x, and then square. You see a couple of points of intersection? So let's go ahead and find them. And this time you need the x's and the y's, so pay attention to those. Okay? So these are wonderful things. We talked before how sad it was for me. I wanted to have one of these when I was learning all this. Alright, number 3, we're back to algebraically. Let's solve them. So you guys should be able to get these 3 problems done hopefully by the end of the period. Maybe not. Give it a try and see how far you can get. Solve algebraically. That means substitution or elimination. Help each other. If you've forgotten what you're supposed to do, coach each other a little bit. See if you can do this stuff.
That would cancel that. That would be, yeah, 'cause it's exactly the same. So,
Did you guys have time to get the first one done? Did you get negative 2, 3 for the first one? Remember, your answer is points. So x comma y. Negative 2, 3. I'm going to erase that. Does anybody have a question about that first one? Worked out great? Okay, keep going. got like 1 minute left. Did this happen for you on this one? So obviously 0 can't equal 8. So that means these lines are parallel. They don't intersect. The math language for don't intersect is inconsistent. And then over here, I got 0 equals 0. You may have gotten 5 equals 5 or something. But it's true. So what does that mean? They are the same line. Now do not say all real numbers, because what are you looking for? Points where they intersect. Where do they intersect? At every point on one of the lines, right? Any point on this line is an intersection. That's called intended. All right, have a great day. See you tomorrow. All right, whole family going? Awesome. Yes.